Welcome. We are NCL Engineering, and today we will be presenting our research on the effect that time and temperature have on the peak strength of soil. So, what is the peak strength of soil? Peak strength of soil is the maximum shear stress that a soil can withhold before failure occurs. In practice, this value is not stable, and once reached, the soil strength will decrease to its final strength. The calculation for peak strength is complicated as there are many factors which can affect this value. Peak strength, denoted by QP, is dependent on a variety of factors such as void ratio, the confining stress, temperature, and time. NCL have chosen to analyse the impact of two of these factors which are very interconnected, time and temperature. Soil strength is of quintessential importance for engineering as soil underlies all foundations of all structures. The properties of a soil have a direct impact on the types of structures that can be constructed in a given area. It is essential to determine the properties of a soil, such as strength, prior to any construction works. The effect of time and temperature on a soil need to be understood to ensure the longevity of engineering work. Area. It is essential to determine the properties of a soil, such as strength, prior to any construction works. The effect of time and temperature on a soil need to be understood to ensure the longevity of engineering works. Typically, over time, soil is compacted by the forces of overlying structures of a material. This increases the theoretical peak strength of the soil. The Leaning Tower of Pisa is a prime example of the effect of time on the strength of the soil. This structure has been built on two different types of soil with different strength values. The soil on the low side of the tower is setting at a faster rate, which is giving the tower its iconic lean. In this case, the peak strength of the soil has decreased over time. Temperature and its rate of change can also play an important role in the soil peak strength calculation. The freeze-thaw cycle negatively affects the strength value of soil due to the expansion of water as it freezes. Generally speaking, soils in sub-zero temperatures have a higher peak strength value than soils in warmer climates. In this presentation, my two colleagues will present a synopsis of various scholar articles on the effects of time and temperature on the peak strength of a soil. They will also present equations to demonstrate how time and temperature factors interconnect in affecting the peak strength of a soil.
As Lewis spoke about in the introduction, the freeze-thaw cycle can impact upon the peak strength of the soil. However, within Australia, these conditions for this freeze-thaw cycle are unlikely to occur due to the climate and altitude of Australia. However, within high altitudes where the temperature is more likely to stay within the negatives for months at a time, the information about how freezing and thawing of soils and their impact on peak shear strength plays a major impact on how foundations are built, whereas Australian conditions are more focused on the impact of how higher temperature soils affect the peak strength of the soil, and this is where I'll be focusing today. A study in Germany discovered the impact in the change of temperature surrounding the soil has minimal impact upon the shear stress. They did this test through using a normally consolidated silty clay. However, what they found was that the stress history of the soil was impacted by the temperature changes, and it impacted more heavily upon the volume of the soil itself. In this study, they used a modified triaxial testing system to determine their results, and this was done through using temperature controlling pads and heaters on the sides of the triaxial containers. Their conclusive results confirmed that over-consolidated soils generally exhibit thermal expansion when heated, causing them to lose shear strength. However, using the graphs that can be seen on the slides that show the QP graph and the M value, as well as the internal angle of the soil, we can see that throughout the temperatures of 20, 40, and 60 degrees Celsius, there's minimal change between the three different temperatures. However, a worrying note is the effect of change in temperature in the atmosphere attributed to climate change, which may impact upon the slope stability of soils. As increased atmospheric temperature can lead to a hydromechanical force on the slope, which can alter the permeability, water retention, and compressibility and the soil shear strength, having lasting effects on the slope strength itself, which may cause more landslips and landslides in the future. Overall, the impact temperature has on the peak soil strength is minimal and can be considered negligible. However, the impact temperature has on over-consolidated soils is that it causes the soil to expand, and this expansion leads to shear strength weakness, whereas normally consolidated soils are more likely to contract when heated. Thank you very much for listening today. Have a good day.
As mentioned by Cooper, the impact of sub-zero temperatures on soil is a rare phenomenon in Australia. However, this field is still important to understand on a global scale. Multiple researchers have noted the calculations for a frozen soil strength is more complicated due to the addition of frozen water and pore ice. This, coupled with the freeze-thaw cycle often experienced in colder climates, adds extra intricacies to engineering calculations in regards to soil mechanics. The strength of soils in sub-zero temperatures are impacted by 4 factors. These are the temperature of the area, the confining pressure within the soil, the strain rate, and the time over which these other factors occur. Now, these 4 factors are all interconnected. As the temperature lowers and the water within the soil freezes, the expansion of this water increases the confining pressure within the soil. The strain rate within the soil varies in regards to the confining pressure and the freezing and melting of pore water. The time at which this occurs also affects the soil's elastic ability to bounce back from the changes in confining pressure. All of these factors must be addressed correctly to model the behavior of frozen soils. Frozen soils are a typical rate-dependent geomaterial, with many theoretical works being proposed to describe the soil's behavior. These are all based on a rate-dependent statistical damage construction model. The failure envelope of a soil can be described by equation 1, where m is the slope of the failure line. However, the position of the failure line has been found to be dependent on time, and so equation 2 provides a more accurate value. A research piece proposes that the time-related parabolic strength envelope for frozen soils in the PQ space can be calculated by equation 3. Now, in this equation, AT is the interception of the envelope on the Q-axis. B is the slope of the envelope when P is equal to 0, and PM is the value of P when the parabolic envelope approaches the maximum value. Now, I know these equations haven't been covered in detail, and our report will provide more detail on all of these equations. It is crucial to understand the effects of time and temperature on the peak strength values of a soil. This is needed to ensure the longevity of structures which will be constructed with soil as the foundation. Both temperature and the passage of time affect the peak strength values of soils. Changes in temperature lead to volume instability in soils with particles such as water expanding or contracting. This changes the confining pressure within the soil and also the void ratio, which are also factors of the peak strength. Soil consolidates over time, leading to an increase in confining pressure and therefore an increase in the soil's peak strength. The freeze-thaw process leads to greater variations in various soil properties due to the expansion of water when freezing. Soils in sub-zero climates have been found to have higher peak strengths due to the confining pressure of pore ice. Additionally, research has shown that temperature changes in warmer climates also causes volume change in soil, which affects peak strength. That summarizes our presentation, and thank you for watching. The topics covered are to be discussed in more detail in the NCL engineering report on the effect of time and temperature on peak soil strength.